As we have seen the change of value of g, like we have seen that at center of the earth the value of g is 0, and if you go like up into the sky at a distance of 3200 kilometers, you find the value of g is 0. So then applications of this based on this g is equal to g into m1 into m2 by d square, that because of this we found some at some places the value of g, and based on that we can decide some things like you know about rocket launching. Like if you want to launch a rocket, like you need some fuel, and why we need a fuel means like it has to go up to the sky, so it has to escape the velocity of this escape the gravitational force. Like if you want to escape the gravitational force, we need to supply some fuel to it. So let us feel that if gravitational force is maximum, then you need to supply like more fuel to it. So in order to avoid that kind of topic, like scientists they select such a places like where g is less to launch a satellite or a rocket. So where the g will be less, it will be less near the equator. So most of the rocket launching stations in the universe, like in the world, they are located near the equator. Means if a country is not near the equator, like they try to search such a location which is near to the equator. In best example is in Sriharikota in India, that is near to the equator, we say in India. Yeah, so that was explained in the first application. Like most of the countries construct rocket launching stations near the equator because at the equator g is minimum, and fuel weight of the rocket will be minimum, and fuel consumption also will be less. And if someone plays at a pole, like so there was a question asked in previous exam, like why people playing near the poles are having, like they get tired very fast, because like there what happens is like the value of g becomes more, and the g is maximum, and as because of this g, that weight, you know, that f is equal to m into g, this weight becomes more. So once the weight becomes more, the players get tired easily. So that is the reason that whenever someone is playing near the pole, they get tired easily. This is what explained by the concept of g is equal to g into m1 into m2 by d square. Now we see that weightless state of a body. This is very important. When you can find the body is having less weight. So you can find when a body is having less weight. Yeah. Now look at the formula of weight. That is W is equal to m into g. When can you find that body is having less weight? So m you can't change, m you can't make it 0. So what you can make it 0 is like you can make the gravitation like g is equal to 0. But where do you find that the g is equal to 0? This is what important for us. Like you can find it in outer space at a distance of 3200 km. That's what we have seen in the application. And you can find it at the center of the earth. And two more important things we need to notice, like in an artificial satellite. You know that in artificial we send some satellites to the earth, like to the sky. So in those artificial satellites also you won't feel any value of g, that g is equal to 0. And in a freely falling lift also g is equal to 0. How we'll discuss these two things now. So now weight of a body in a lift, we'll discuss what happens to the weight of a body in a lift. Let us say this is a lift and this is a person, like what happens, like we'll discuss 4 cases. The first case is like before getting into the first case, like what happens to the weight. See, in general the formula for weight is nothing but mg, but when you are in a lift, like lift also exerts some acceleration. So because of this acceleration, like weight of a body changes from f is equal to m into g to m into g plus a. So like your force of attraction will become maximum. So g will be maximum, like g will be like additionally added by like a. This is what like, acceleration of the lift. Yeah, case 1 we discussed, like when a lift is standing in position, it's not moving at all, so there won't be any acceleration because of the lift, so it is 0. So the weight of the body will be constant, like mg in general. What it is, the same will be in the lift when it is in the car, like when it's not moving. The case 2 is like when lift is moving upward. Even you find like when you are moving in a lift, like your like weight of the body has increased because it has showing some acceleration towards like to up into the sky. So because of that, this that acceleration is positive acceleration, so the weight will become m into g plus a. So the weight increases. And when the body is moving downwards, it is moving downwards, not freely falling, it is moving downwards, like so when it is moving downwards, that acceleration becomes negative, a is equal to minus a. So then weight becomes f is equal to m into g minus a. It means that the weight decreases. So in a lift, when you move up, the weight increases. When you move down, the weight decreases. This is opposite to the like nature. like in a on the earth, if you move up, like the weight of the body decreases, and if you move down, the weight of the body increases. But in the lift it is opposite to the things. And if the lift is falling freely, means generally what happens to the lift is tied by a rope. Because of this, it is having some particular acceleration. So if there is no rope, then it is freely falling, means it's simple body, normal body of freely falling. So when it is freely falling, what happens is, like, the acceleration of the lift will be equal to the value of g. So when a is equal to g, you can see that the what happens to the weight of a body, that will be m into g minus g, so that it will be equal to 0. So like when a rope of the lift was broken, the people will go gaga, like they feel like, oh my god, what's happening. So because they won't feel their weight, like they won't realize what is happening also, the weight of the body will be equal to 0. This is what about the weight of a body in a freely falling lift. So weight of a body in a freely falling lift will be 0. So when do you feel the state, like weightless state of a body? Like at 4 cases. One is outer space, one is in artificial satellites, and at the center of the earth, and as well as in a freely falling lift also. This is what explained by a lifter. And before getting into the artificial satellites, you need to know three velocities. One is the takeoff velocity. What is the meaning of takeoff velocity? Name itself is giving that the velocity required for a rocket to take off from the into the space actually. So this is represented by Vt. Minimum of that rocket should go with a speed of 2 kilometers per second. So that then only that it can like go into the sky. So this is what takeoff velocity. And second one is orbit velocity. What is the meaning of orbit velocity? Like an artificial satellite, once it entered into the sky, like then the next move is like it has to move into the in an orbit of around the sky, around the earth actually. So this like round is called orbit. So it should move in orbit. So like if the rocket has to, like satellite has to move around the orbit, like around the earth in an orbit, the velocity needed is called orbit velocity. That the velocity is 7.9 kilometers per second. That is what about. And artificial satellites, when you send those into the sky, so at a height of 35,786 kilometers, approximately 35,800 kilometers, so they can move into the around the earth. This is what happens. From the equator, if it reaches 35,800 kilometers, then it makes revolutions around the earth. That is what important thing we need to know about. And we know that the time of revolution for the artificial satellite is equal to the time of rotation of the earth. So because the time of revolution of the artificial satellite and artificial of the earth both are equal, then only that we feel that satellite is not moving to place. So the generally satellites are sent for a particular purpose. Let us say this is a globe and somewhere here India, you send a satellite over here, and if the time period of this earth and the time taken by the revolution of the earth and time taken for the revolution of the satellites differs, then you see that the satellite moves here and India will be here. So that is the problem. So that is the reason that the revolution of this artificial satellite is fixed for 24 hours, so that in 24 hours it make a complete revolution around the earth. At the same time, earth also moving in a 24 hours, so you won't feel that the satellite doesn't move away, so it stick to the position of India only. That is what about the orbit velocity or orbital velocity. And the third one is escape velocity. And escape velocity is such a velocity it is required by a rocket to escape itself into the space away from the earth gravitation. So first one is if it want to move into the sky, it has to move with a certain speed. That velocity, that is takeoff velocity we say. Escape velocity is a different thing. It has to move at such a speed, it has to escape this gravitational force. It should go out of the gravitational force. That escape velocity required is 11.2 kilometers per second. So this is what escape velocity is. And now you see a geostationary satellite. So this is a geostationary satellite, like a satellite, artificial satellite we say. So it moves around the earth, and they revolve around the earth within a time period of 24 hours. That's what we have seen. The first Indian artificial satellite is Aryabhatta, and some of the applications. Why do we use artificial satellites? For weather forecast and to find the areas. Nowadays we can see that for navigation purpose, and for space research, and for to find agricultural needs, to find areas of crops, and geographical mineral wealth, to find the geographical mineral wealth and sea wealth, to measure the sea wealth, and mobile communications, fax and internet, etc. These are some of the applications. Not only these, these are some of the applications of geostationary satellites. So this is what about universal law of gravitation. Because of this only these things happens. So this is what about the topic, friends, for today's topic. So don't forget to subscribe our vFocus channel in YouTube, and also like our page at www.facebook.com/vfocus classes. So thank you very much and have a nice day, and don't forget to inform your friends about the vFocus classes. Stay tuned to vFocus.